This video will continue our discussion of section 4.6. This is variation of parameters with another example. So I see that on the left side, we have constant coefficients. On the right side, we have a function now. So this is a non-homogeneous diffie-q. So starting off, I'm going to solve the homogeneous case. So that's y double prime plus y equals 0. And then just be very careful here. That is a 1, not an m for y, right? Our derivatives only pick up m's. So this tells me then, if I solve that, that m is plus or minus I, right? Following the forms that we've had in the past sections, this is going to get me e to the 0x times c1 cosine of x plus c2 sine of x. I'm going to rewrite this. I don't need the e to the 0. That's just 1. And this makes our functions much easier. So, okay, now I have that solution. We'll use that in the end. And then for variation parameters, remember, we're gonna assume now that our y sub p will be u1 times y1 plus u2 times y2. That's what we're assuming. Y sub 1 is going to be our cosine x. Y sub 2 is our sine x. All right, so we'll set up our Wronskians and solve. So my first Wronskian of y1, y2, okay, is going to be y1 is cosine, and then I take my derivative going down. The second one is sine, and then the derivative is cosine. All right, if you were to take your discriminant there, cosine squared, and then you can see a minus, but it's going to be a minus negative, so it's a plus. So we get cosine squared plus sine squared, we get a nice pretty 1. All right, we're going to find w1 now. W1, remember, we just put 0, and we put the function that was on the right side up there. And then sine x, cosine x. All right, if I were to multiply that out, okay, 0 times cosine gets me a cosine. But secant squared times sine, I can take that's 1 over cosine squared. So I can take that and put it with sine. So I'm going to get secant x tangent x. Okay, and then I'm going to shrink this up just a bit so I can put my W2 in the same line. W2 is going to be, we keep the original ones, and then the functions. Cool. All right. And then now our multiplication here, secant is 1 over cosine, so I'm just going to get another secant here. All right, I have all three. So we can now go after our u1 prime and u2 prime. u1 prime is w1 over w. So w1 is the secant tangent over 1, so we just get a secant tangent. Right? To get u1 then, I just take the integral of that. And thankfully, that's a nice, pretty integral. The answer here is just a secant. All right, hold on. I got a negative in my, somewhere in my, oh, hey, this should be, I'm glad I have notes. That should be negative. Some of you guys have probably been screaming at me the whole time. That's negative. That's negative. There we go. So we get a negative secant. All right, so we have that for u1. u2 prime is w2 over w, which is just going to be a secant. And then we got to find u2 by doing the integral of secant x dx. There's a trick to this one to do by hand. The trick is multiply top and bottom by secant plus tangent. This trick works every time you have a secant. If you had a cosecant, you do cosecant cotangent. Um, with a negative in there somewhere. Okay, so we have this. If you take a look, if the top is, I guess we can just keep going. We got room. The top, I'm going to flip this just to make it a little more obvious here in a moment. I get secant tangent plus secant squared. I just distributed and flipped it. All right, the reason I did this, is if you do a u sub now, u of secant x plus tangent x, the derivative is exactly the top. Secant x tangent x plus secant squared x dx. So that would be the integral of 1 over u du, which is ln of u, so it's just going to be secant x, ln of secant x plus tangent x. All right, so we have u1, we have a u2. Now I can find my particular solution. Particular solution is going to be the first thing, which was negative secant, times y1, which was cosine, plus the next, which was the ln of secant plus tangent, and then times, I think it's sine. Yep. There's my particular. We could clean this up a little bit because secant times cosine is a -1 plus, and then I like my sine up front so we don't mistake it to be inside the ln. Doesn't matter though. All right, so there's y sub p. So y, then my final solution is going to be c1 cosine x plus c2 sine x minus 1 plus sine x times ln of secant x plus tangent x. And there is my solution. So it really